The James Webb Space Telescope has made a discovery that could shatter our entire understanding of the cosmos. It found fully formed galaxies that existed a mere 300 million years after the Big Bang. And frankly, they're breaking our understanding of physics. This isn't just a minor anomaly or a small tweak to our existing theories. This is a fundamental challenge to the very foundation of modern cosmology. For decades, we have been operating under the assumption that we had a fairly solid grasp on the timeline of the universe's evolution. The Big Bang, followed by a dark age, then the slow, gradual coalescence of matter into the first stars, and eventually, over billions of years, the formation of the majestic spiral and elliptical galaxies we see today. This new data from the JWST doesn't just poke a hole in that narrative. It blows it wide open, forcing us to confront the possibility that our most cherished models of cosmic history are deeply, fundamentally flawed. These newly discovered galaxies are far too massive, far too organized, and far too mature to exist so incredibly early in the universe's history. According to our current standard model of cosmology, the lambda cold dark matter model, at just 300 million years after the Big Bang, the universe should have been a very different place. The structures that existed should have been nascent, just beginning their long journey of formation. These newly discovered galaxies are far too massive, far too organized, and far too mature to exist so incredibly early in the universe's history. According to our current standard model of cosmology, the lambda cold dark matter model, at just 300 million years after the Big Bang, the universe should have been a very different place. The structures that existed should have been nascent, just beginning their long journey of formation. But that's not what the James Webb Telescope found. Instead of cosmic infants, it found what appear to be cosmic adults. The light from these galaxies has traveled for over 13.5 billion years to reach us, giving us a snapshot of the universe in its extreme youth. Yet, the galaxies in this snapshot look impossibly old for their age. They are not the small, chaotic clumps of matter our models predicted. Instead, they appear to be massive, well-ordered systems, some potentially as massive as our own Milky Way galaxy. This is simply staggering. To put it into perspective, it's like looking back at what should be the kindergarten class of the universe and finding a fully grown 30-year-old adult sitting amongst the toddlers. The discrepancy is so vast, so utterly profound, that it has left astronomers and physicists around the world scrambling for an explanation. The evidence is undeniable and deeply perplexing. These early galaxies don't just possess unexpected mass, they also exhibit a level of structural complexity that should have taken billions of years to develop. Some of them appear to have distinct features like spiral arms, which are hallmarks of a mature, dynamically settled galaxy with a long history of rotational evolution. The formation of such a structure requires a stable, rotating disk of stars and gas, a feature that was thought to be a product of a much later cosmic era. Furthermore, the light signatures from these objects suggest the presence of older, redder stars, implying that significant star formation had already been underway for a considerable amount of time. The universe was simply not supposed to be able to form stars and assemble them into such ordered structures so efficiently and so quickly after the Big Bang. Even more baffling is the potential presence of supermassive black holes at the centers of these ancient galaxies. Supermassive black holes, millions or even billions of times the mass of our Sun, are believed to grow over time by accreting surrounding gas and dust, and by merging with other black holes. Our models for their growth are gradual, requiring vast stretches of cosmic time to reach the sizes we observe in the local universe. Finding evidence of them in galaxies that existed only 300 million years after the Big Bang presents a monumental seeding problem. How could these behemoths have grown so large, so fast? It would require them to accrete matter at a rate far exceeding what was thought physically possible, or it would imply that they were born from seeds that were already massive to begin with, a concept for which we currently have no mainstream theoretical basis. The implications of this discovery are shaking the very pillars of astrophysics. If these observations are confirmed, and are not the result of some unforeseen observational error or misinterpretation of the data, then our standard model of cosmology faces a severe crisis. The Lambda CDM model, which has been incredibly successful at explaining a vast range of cosmological observations, from the cosmic microwave background to the large-scale structure of the universe, is predicated on a specific timeline. It dictates the rate at which structure can form, governed by the interplay of dark matter, dark energy, and ordinary matter. These galaxies, with their immense mass and advanced structure, simply don't fit into that timeline. They formed too fast, grew too big, and organized themselves too quickly. This discrepancy forces us to consider radical new ideas. Perhaps the process of star formation in the early universe was vastly more efficient than we ever imagined. Maybe the first generation of stars, known as population 3 stars, were supermassive, living fast and dying young in cataclysmic explosions that rapidly enriched the surrounding gas with heavy elements, thereby accelerating the formation of subsequent generations of stars and the galaxies that house them. Or maybe the nature of dark matter is different from what we assume. Our models rely on cold dark matter, which moves slowly and clumps together gravitationally over long periods. If dark matter were warm or had different properties, it could potentially alter the way structures formed in the early universe, though most alternative models actually predict a slower formation of galaxies, not a faster one. The very chronology of the universe could be in question. Could it be that our timeline of the universe is completely wrong? While the age of the universe, approximately 13.8 billion years, is a well-established figure derived from multiple independent lines of evidence, some fringe theories have proposed that the universe might be older, perhaps twice as old as we currently believe. This would provide the extra time needed for such massive galaxies to form through conventional processes. However, such a radical revision would require us to abandon our understanding of cosmic expansion and the physics that underpins it, a step that most scientists are extremely hesitant to take without overwhelming evidence. Another, even more speculative possibility is that something else entirely created these galaxies. This line of thinking pushes us to the very edge of known physics. Could there be some unknown physical process, some new force of nature, that operated in the extreme conditions of the early universe, allowing for the rapid formation of large-scale structures? This unknown something would have had to act quickly and efficiently to bypass the slow, gradual process of gravitational collapse that forms the basis of our current models. It's a tantalizing thought that hints at a universe that is far stranger and more complex than we have ever dared to imagine. It suggests that our current inventory of particles and forces might be incomplete. Ultimately, we are left at a crossroads, facing a profound and exhilarating mystery. The James Webb Space Telescope was built to answer questions about the early universe. But in a wonderful twist of scientific discovery, its first major findings have generated even deeper and more fundamental questions. Are our meticulously constructed models of galaxy formation wrong? Is our understanding of the fundamental components of the universe, like dark matter, incomplete? Or, in the most extreme scenario, is our entire cosmic timeline, the very story of the Big Bang itself, in need of a radical rewrite? We stand at the precipice of a potential revolution in cosmology, all thanks to these impossible galaxies that, according to our best theories, simply shouldn't exist.